Right, folks, well, we're going to move back on to this, the Mega Tracker CB1100, but this isn't the customer one, which we showed you before. This is my one. So by looking at the customer one and this, Mr. Chippie's been able to put back all the missing links and diodes that have been cut away on this one, which had been converted to 10 meters. He tells me there's a padded capacitor across the trimmer and a wire link on this one, which isn't on the customer's one. So the plan is this: if we can get our one to work, we can then look at the voltages on the receiver of ours and hopefully fix the customer's. But that's not all. Sounds like one of those American TV ads. No, because we found out what this is. I had a brainwave, and I remembered. Now, can you all remember? We've done several of them over the years, of those PE Ranger 6 crystal controlled channel half-watt transportables, which were a magazine project in practical electronics, and they weren't cheap and they're not particularly reliable, but there you go. And I remembered something, and that was the magazine which bought up Radio and Electronics Constructor was called Radio and Electronics World, and at one point it was owned by Ambit, who became Circuit with a C, CIRCIT. Was it Milton Keynes they hung around? Anyway, it eventually petered out after about 3 years. And they were going to do a CB radio project, and then it got shelved. And then they produced this in kit form. So this is a commercially produced, probably even by the person who designed it, version of the Radio and Electronics World project. Now, the way they had to do this project, they had to supply the board ready built, ready aligned, and you just put it in the case. That's not necessarily this isn't this case. It's not a Mega Tracker. And there we have it, the article. The R&EW 40 channel CB rig. And if I can find a date, April 1982. So they've missed the boat really. So there's the circuitry in detail. There's their case, which is a non-printed version of what you see. And there we have the layout. There we have the layout if we have it that way on. Channel selector, big chip, thingies, what's it, transformer, choke thing. That's the set. And what the setup procedure is. So the board came ready aligned, you put it in a case, and then it was all legal, but there was alignment procedures. So this isn't like enough information. It's not like having a service manual. Luckily, some of the big explanations is how the receiver works, and some of the other big explanations is how the synthesizer works. They wanted something which you'd be able to convert to 10 meters. And there we have the IC, which is based around the Motorola MC 145151. So, with this information, it's in 2 parts. So we've got April, is it May then? Yes. Yeah, April and May. 1982. So that website has got all the American radio magazines and the UK ones as well. They have got this, and I downloaded this from there for these printouts, but I do own those magazines, but they're in the loft, so rather than scan mine, we've done theirs. So Mr. Chippie's done this. I'm going to power this up. It isn't likely to just work. It's going to need things doing to it. Perhaps we should have tested it to see whether it worked at all as a 10 meter set, or whether it was a failed project. I've no idea. so there we are, we're now powered up. And if it's supposed to have a meter lamp, it doesn't. And our PA socket's missing for some reason. So we've got an FM hiss. That's the speaker. We haven't got that on the customer set. No idea what that is. Oh, it goes to the PA switch. I think it's been disabled on this and turned into somebody's play toy. Bit noisy volume control, so I'll deal with that. So just be clear, this is my set, not the customer one. We'll look at the customer's one again, basically if we can get this working. If we can't, we've not really got much chance of getting his working. So I'm going to put into the signal generator 2779125. We'll have the thing on channel 20, and let's just show you where I am and put picture in picture on. 2779125. It'd be lovely if it just started working, wouldn't it? I'm probably not the only person in the country to be able to do this, attempt to do this, but I think we've got a fighting chance. You can tell I'm getting old when I'm starting to remember magazine articles from 1982. So there, we're about on frequency. So I've got the signal generator on full, and we're not receiving anything. Right, so we're going to the main meter. I'll press transmit on the radio, and we're not doing anything. So I'm going to put the little walkie-talkie on, turn the signal generator down, which it's receiving, and it's not receiving anything. So it's not generating any channels, so we'll have to see what the phase lock loop setup procedure is. It's bound to be weird. So now we've identified what these sets are. I think that's helped the radio world immensely. Oh, where's my other glasses? Setting up. Switch on and check power consumption. In the CB mode, the current consumption is around 500 milliamps. We haven't got a meter lamp running. And you should have a characteristic FM hiss from the loudspeaker. So we have. Adjust the trimming capacitor on the phase lock loop crystal for 10.24046 at pin 26 of that IC. So we'll get our, instead of doing it with a frequency counter, we'll do it with the oscilloscope, especially if I know where there's a probe. Why? Right, well this will do. Get negative onto one of those. And we're looking at pin 26. And how many pins is the IC? Uh, 20, no idea. because it's been covered in wax, that doesn't help either. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, I think it's 28 pin. So 26, it's right in the middle of the wax. Right, so we're going to remove that powder capacitor because it won't go on frequency. So I've turned the set off, I've not turned the soldering iron on, so now we'll sit there waiting. I'll just remove one end for now. Mr. Chippie didn't take that off just in case. So just lift one end. Leave that in place just in case. Switch back on. See if we can get our connection back. Four, 6. So we are 2404 toggling 5. So as far as I'm concerned, that's on frequency, because you'll trim that later to be spot on. Good. That's not going to suddenly make it work. Tune transformer 8 to provide maximum signal at pin 1 of IC1. Not sure how we're going to get maximum signal. We've not set the lot. Which is T8. No, we're not messing with the receiver at this stage. We need to make this thing lock. Set transformer 4. So hopefully that's that one. It is. So the lock detector remains high at all positions of the channel selector switch during transmit. So this is your VCO. And what we're looking for, pin 27, so I'm putting the setting to transmit, that's been waxed. Right, it moves now. Absolutely nothing. Let's have a twiddle with on receive. Right, well, make sure I'm not on a false lock point. Well, we've got 30 microvolts on the signal generator at the moment. So I've not got transmit. Now RV7, this should never have had wax put on this. That's so stupid. So my logic is, I'm hoping what? To be honest, it's like it's not going into transmit. So let's have a quick run through the receive. Just run through some of these by ear. So T1, 5 and 2. That's those three. Yeah, well, I mean that's enough to. That's 3 microvolts. That's quite promising. I'll go into our. They're not expecting you to have the level of instrumentation we've got here, so I'll just run through it our way rather than the instructions way. So I'll just plug in the test instruments into the speaker socket instead. I can hear the speaker, but you can't. So go over to the oscilloscope. and that's probably going to be the detector, because T3 and T9, yes, it's that one. For some reason that doesn't fit, and oh, even though you'd think it was the right one. Try that one. That was already spot on. Well, I'll go to the SINAD meter and just see what we can do. That wasn't the nicest waveform I've ever seen. Just see where we are with the transmitter, T8 and T7. So that's transmitter. T8, 10 and 7. No, it could be 6, 10 and 7. So those three look to be the transmitter. I just want to make sure we know where we are. So we don't have an awful lot of adjustments in the front end of the receiver. What's T11? Have I overlooked that? I can't actually see it. See whether it affects receive. Yes, it does. Dramatically. I think that was on a false lock point where I first had it. That was miles out. So at the moment we've got 0.95 microvolts for 12 dB SINAD, which is probably about where we're going to be. So I'll now return back to a speaker we can all hear. Right, so I'm pleased with that. So we're back to this no transmit situation. So here's the next question. Is it now transmitting a few inches? So I'm going to upset the VCO again. There, we've got transmit. But it's nothing coming out. So then we have to adjust this preset So we get lock on receive, which we now have. So now we've got lock on transmit and lock on receive. So now all we've got to do is try and make the damn thing transmit some power. So at the moment we're drawing 320 milliamps. So looking at the transmit sequence, it's going to be I think that must be T6, T10 and T7. 6, 10, 7. I'm guessing these need to come up. There she blows. Put the main meter on. So it's doing 1.8 watts. Go and change scales. We've gone beyond. We're beyond 5 watts at that. Right, so we can turn that off. If I understand right from what I read, that's low power. Looks a right bodge, but it is. So stick it on low power. Well, it's not very low at the moment. Right, so what we've got these others to tune. And then we'll read how to drop the power to 4 watts. And that's strange. You'd expect those to be miles out if it's been on 20. I don't think this ever worked on. I think it was a failed conversion. Right, let's see how we drop the power. It's just under 6 watts at the moment. Let's just see if it's on frequency. So it's a bit high, so we'll just drop it with that trimmer. Brilliant. So deviation, I know I haven't done the power yet. Wallow, wallow, wallow. Hello. Wallow. 1, 2. Yeah, we'll worry about that on the other test set. That doesn't look at all. I'll just try once again. 1, 2, 1, 3.5. So it's VR5. That's 6. That's 1. Hello, where's 5? Is it that one? That's 4. So 1. See if I can find it on the layout. 7, 1, 5. It shows as being there. Well, I wonder if it's that one. That's the one which I can't find a label on. Wallow. That's the one. We'll check it, double check it on the other set. I'll just listen to myself. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And it should be really good with that speech processor. So that's that. The power. So something's amiss with low power. Tune all the RF stages or best RF output. Repeat until 4 watts is available. And VR6, it's VR5 and VR6 between, so is the deviation. So I'm just wondering, have we got S meter and RF meter? We'll look at the circuit diagram. VR1 should be the meter on the front. which it is. That's tuned it to 4 watts by detuning the final coil. See what it is on the other channels. Channel 40, 4.2 watts. Channel 1, 4.1 watt. Channel 20, it's risen now, it's cooled down a bit. We'll just drop it a little bit more. We're dead on the 4 now. Dead on the 4. 4.1. Low power, let's just give it another go. Tell you what, we'll work the switch a bit in case it's dirty. So that needs looking into. Before we do an on-the-air test, I will see if there's anything we can do with that. Hang on a minute, what's that in the corner? Is that low power? Yes, it is. Or is that high power? It's high power. See, these instructions just... So now we can retune the transmitter back to where it was for maximum. And turn down the power with that preset, which we didn't know existed. That's now spot on the 4 watts. Check it on the other channels. Channel 1, 4 watts. Channel 40, 4 watts. It's gone down evenly now. Switch it to low power. And we're still banging across. So I don't know what's amiss with that. So, does it have an S meter? It does, and that's 100 microvolts. So let's just see if that's adjustable. There's no preset for Squelch. So what you see is what you get. VR4 is receive meter. Which that one right at the front there we go, we're set for S9. We'll have to look into why the meter doesn't light up. And I'll go through the receiver again. Now it's all on frequency and all that. So that's our set just about done, and with this information we'll see if we've got a fighting chance with looking at the customer's set. Right, we're going to draw this to a conclusion so that we can do a scratchy corner test on it, because we're going to be very interested to see that. I've just gone through the receiver again just to see whether I can get that extra ounce. Now it's all on frequency and everything's doing everything as it should be. So I'll just put the SINAD meter up, and of course we're filling the form in, but there were no befores because it was converted to 10 meters. I don't think they'd succeeded either because of, you know, you got if I didn't have to adjust the two transmitter PA ones at the back there, well, it can't ever have been on 10 meters. I just think they'd failed like they usually do. Right, we've now got received down to 0.48 microvolts. So you remember when I did the rough tune, it was 0.95. This is, of course, going to be quite a selective set because of all the extra filtering it has and more expensive filtering. It's kind of set which you'd find would be £200 at the time, I would think. I don't know what they sold for, but that's the kind of quality. These days, £229 set gets you a £59 set, but loads of bells and whistles on it. 0.4. 20's not brilliant. It's all down to noise, so it's 1.8. Doesn't matter anyway. And that's Squelch. Let's go back to a speaker we can hear. Let's see where the Squelch is. So I'll put the attenuator up on the inset picture. So I've got Squelch to full on the radio, so we're at 3 microvolts, 10 microvolts, 30 microvolts. It is 30 microvolts. So I've seen worse, but it could be a bit weak in a town. But that is not adjustable, that's how it is. That's threshold set, and let's see what it is on sensitivity. Wow. 3. So that's good. Right, so the things we're not going to do at the moment, we're going to move on to the customer's one and see if there's something we can do to fix his. There's no promise we can. But the reason we've done this and done all the research is so that we can fix his. And if I'd have thought previously about this, we could have had this working years ago. I didn't actually need to see another one, I just needed some of the details on here. Right, I just need to spray the volume control, it's a little bit noisy. Good. So, at the moment, the PA socket has been removed, and the socket, the switch has been wired to 2 wires, which went to a subboard to make it probably do 10 meter repeater shifts. So that's the first thing. So we're going to see, Mr. Chippie's going to see if he can find a socket that fits, and then we'll copy the customer's wiring or look at these circuit diagrams and see if we can restore PA on this set. I'm not going to be showing that on any video. That's that. Low power isn't working. So this red wire goes to this kind of afterthought preset, and when I press the switch, absolutely nothing happens. Let's have a look. So we've got that wire and we've got a green wire. So what I would like to do is to get the meter to light up. That would be nice for this test. So I don't know what that link does, but everything's working absolutely fine with that in, which isn't there on the customer's one. So let's just see if I can get into this meter. So when I open this setup, it's a matter of taking the nut off the channel selector switch, the sides apart, and just pulling it forwards to extract the meter. And there's a festoon bulb on this sub panel, so I think what we'll do, we'll put a wire-ended lamp in, but I may have to change the resistor value. We haven't got festoon ones, goodness knows where they came from. So we're putting in an RS655992, which is 12 volts, but I can't remember how many milliamps it is. Right, so with the meter lamp, let's take picture in picture off. Meter lamp's done, and I didn't realise it's on the dimmer with the LED display, which is nice touch. Not many sets do that, but there are one or two. Just going to check the deviation into the meter just to make sure we're right. Wallow, wallow. Could be very, very slight. I think it's 2.7. Wallow, 1, 2, wallow. There we are. So just make sure that sounds like a radio. Testing 1, 2. Testing 1, 2. It does. So that's it. I don't think we might connect the speaker for the on-the-air test. But that's it. That's where we are. We're going to just pop it on the aerial, see if we can hear any good buddies out there. I'll switch my test gear off. I'm really chuffed to have got to the bottom of this one, and it gives us a fighting chance of getting to the bottom of the customer's repair, which is why we've gone to all this trouble and expense. Don't know who Jeff is, but he's inscribed his initials in the side of the chassis just there. So as you can see, the dimmer dims the meter lamp as well. One and a Roger. And 19 a Roger. You know what, you'd think it was as deaf as a post, but it isn't. Now the filtering on this is better than most sets. Certainly better than the Magpie and the EMS Mercury British sets. There's another level of filtering on these, and the crystal filter and the extra ceramic filter. So there's a lot of filtering. So you'll find anybody who's either off frequency slightly or over deviating slightly will sound absolutely dreadful. Thanks for watching the Mega Tracker CB1100 Part 2. In the next part, we'll see if we can get the customer's one to work, or whether it goes back as it is.